A stone is released from rest and falls vertically. Air resistance is negligible. What is correct about the stone during each consecutive second of its motion? Option A, the change in velocity is constant. First of all, velocity is a vector quantity. It may change due to direction and due to its magnitude. It's always in the same direction, so it doesn't change due to direction. And we know that the final velocity is equal to the initial velocity plus acceleration times time. So the final velocity is equal to u is 0. It's the initial velocity is 0 because it starts from rest. A, it's acceleration due to gravity. It's in this direction because it's free fall. So the final velocity is equal to gt, and it looks like an equation of a line mx plus c, where g is gradient, and it implies that for every additional second v changes by g. So it changes by g for every additional second. So the change in velocity is constant. It's true. Or you may consider directly that when t is 1, v is g. When t is 2, v is 2g. When t is 3, v is 3g. So you can see that it changes linearly, plus g plus g. So A is correct. D is not correct because speed is magnitude of velocity, and the change in speed is also constant. The change in acceleration decreases is not true because acceleration is always equal to acceleration due to gravity g. The change in displacement is constant. It's also not true because displacement is ut plus at squared over 2. U is 0, so displacement is gt squared over 2, and when t is 1 it's g over 2, when t is 2 it's 4g over 2, when t is 3 it's 9g over 2. So you can see that it's plus 3g over 2 plus 5g over 2. So the change in displacement is constant. It's not constant. The next, a projectile is launched horizontally from the top of a cliff with a speed of 10 meters per second. The projectile hits the ground at a distance of 30 meters from the base of the cliff. Air resistance is negligible. What is the height of the cliff? So the initial velocity is horizontal, and the vertical displacement is this distance, and it's the height of the cliff which is required, and the horizontal displacement is this distance, and it's 30. We know that displacement is ut plus at squared over 2. Air resistance is negligible, so acceleration is acceleration due to gravity g, and it's in this direction. So if we say about the horizontal displacement, which is 30, is equal to the horizontal component of the initial velocity, it's 10 times t. Acceleration due to gravity is perpendicular to the horizontal direction, so its horizontal component is 0, or its projection on the horizontal direction is 0, or it means that it doesn't affect on the motion in horizontal direction. So time of flight can be found. If we consider the vertical displacement, let y-axis be downwards. So ut, the vertical component of the initial velocity is 0. G is in the same direction as y, so it's plus gt squared over 2. And if you know time of flight, you can substitute 3 for t to find the vertical displacement, which is equal to the height of the cliff. So it is equal to, it's approximately 10, it's 45 meters. C is correct. The next, a projectile is launched with the initial velocity v at an angle theta above the horizontal. The projectile lands at the same height from which it was released. Air resistance is negligible. What is the time of flight of the projectile? Vertical component of the initial velocity is v sine of theta, and since air resistance is negligible, it lands with the same speed. And if we say about the velocity, it has the same magnitude, but it's downwards. So the magnitude is also v times sine of theta, but in opposite direction. And we can use that the final velocity is equal to the initial velocity plus at. Let y-axis be upwards. So the final velocity is negative v times sine of theta is equal to u is positive v times sine of theta. Acceleration is in this direction, so it's minus gt. Hence, time of flight is equal to this to the left, this to the right, 2 times v times sine of theta over g.